and trying to figure out what is important, what should I say, and if I say something should not be out of context, it's got to be in context. So those are some of the challenges that I faced. But I guess what I'm going to do today is I will very quickly go through some of the slides. So please forgive me if I don't spend a lot of time discussing the slides in detail. We can take the interesting topics in the question and answers. So to start with, everything that I'm saying is evidence-based. There's got to be some kind of either text evidence or evidence of practice that we want to see whenever we claim some of these things. So towards that, I present these things. Where are the instances of astronomy found in the Vedic literature? All of these texts, whether it's in the Samhitas, Brahmanas, Aranyakas, Upanishads, all the way to Siddhantas, mathematical astronomy works, we find instances of astronomy. So no surprise there. It's scattered all over the place. And if you look at the roots of astronomy is called Jyotisha Shastra in India, and it's concerned with these things: cosmology, cosmogony, earth studies, astrometry, position of nakshatras, planets, planetary studies, orbits of planets, comets, time studies and calendars. And we also have astral studies, predictive Jyotisha, and mathematics to model celestial movements. And the tools that our ancestors used are various yantras to do these. And there's a parallel with modern astronomy. And no surprise there, because modern astronomy also is concerned with cosmology, origins of the universe, astrometry, position of stars, planets, planetary signs and comets, asteroids and other things, stellar astronomy, life cycle of stars, galactic astronomy, astrophysics, astrobiology, and the tools we use today are telescopes, radio telescopes, space telescopes. But what you see here is a connection, right, from a very ancient time. The things that our ancestors did have expanded and progressed to what we call modern astronomy today. And I put a timeline over here to show you some of the things that I have researched and I talk about in my lectures at Hindu University of America. We can show the origin of mathematics and astronomy in a very ancient period of time and has transferred out of India in different periods. We can show in 2000 BCE how, following a monsoon failure, there's been export of Indian knowledge to the Fertile Crescent, meaning Mesopotamia, Anatolia, Egyptian and Nile Valley and other such places. And in India, there's a long citation trail for mathematics and astronomical works. And we come to the Siddhanta period itself, where we see transfers going out to Neo-Babylon around 600 BCE, contrary to what Western historians say that Indians learned from Babylonians. Going forward, during the Roman-Greek contact and the Indo-Roman trade from 450 BC all the way to current era, once again, we see through Library of Alexandria and other kind of transmission mechanisms, we find that Indian knowledge has gone out. Going forward, we have Aryabhatta, we have a whole lot of other astronomers, and then we come to the Islamic period. After Bin Qasim's invasion of Sindh, Indian Sanskrit texts taken and translated in Baghdad, things like Brahmasputra Siddhanta and others. Please don't annotate. Can I request you, Padmaja, please don't annotate. And organizer, can you please erase these annotations too? There's an erase button. You can use that to erase these things. And if we go to the Islamic period, when knowledge went out to Baghdad and from there translated into Sanskrit, into Arabic and Persian, and from there into Europe, into Latin and other such languages. Going on in India, we see Bhaskara, we see transmissions once again from the Toledo, from Islamic areas going on to Latin Europe in Toledo and diffusing to Europe in 10th to 13th centuries, literally. Then in India progresses on to Kerala school, and we see direct transmissions to the colonials, 15th to 20th centuries. And around that time, 1600s and so on, the telescope was discovered in Europe, and it gave rise to what is called modern astronomy. But it forgets the roots. The roots have a long, long tradition, and that's a thrust of what I'm going to talk today. If you look at the evolution of Bharati astronomy, we see that very early on, observations are woven with philosophy, comes in a philosophical content, the Samhitas and other places. Then eventually we see in the Puranic literature, especially where there is astronomy wisdom is encoded into stories with metaphors. And around that time, probably also mathematics was used to model celestial body movements. It's a gradual development. We see that initial models were simple, and then innovations are there that make it better and better over time. So the gradual development over here. And later on, by the time we come to Kerala school, we see very advanced mathematics and theories of celestial body behavior and so on, the later periods. And if we take a look at sources and texts, like I said, we have a long citation trail, right from the Vedas, Brahmanas, and those works. And Siddhantas are, like I said, containing mathematical astronomy works. And we have got reference to a whole lot of Siddhantas, which we don't have access to. They're lost. But we know they existed because there are citations to them. Later writers cited those early works or wrote bhashyas on them. Therefore, we know that these works existed. And we can only speculate what might have been the mathematics in these early works, what their time periods are. We don't know much about these things. Then going on to Vedanga Jyotisha, the 1400 BC, attributed to Lagada, going on to Vritigarga, the Surya Siddhanta, and several other works, for example, the Paitama Siddhanta, Lomasa, and others, commentaries by Varahamihira. That is why we have access to these works, but the works themselves have not survived. And going on to Aryabhatta, who wrote Aryabhattiyam, Arya Siddhanta, which we don't have. We have Aryabhattiyam. And Varahamihira, who wrote Panchasiddhantika Bhashyas on these 5 works, thanks to which we have knowledge of what existed in those Siddhantas. Bhaskara I, who wrote his Bhashya on Aryabhatta's works, through which we have an understanding of what Aryabhatta meant. Then Brahmagupta, Vateshwara, and many other great people. Going on to Bhaskara II, Siddhanta Shiromani, Parameshwara, and others of the Kerala school, Ganesha Daivignya, all the way to Chandrasekhara Samanta and Odisha, and so on. So why am I showing this? To show a long connected trail. For people who say that Indians have copied from the Greeks and the Babylonians, we have got news for them. We got a citation trail going back to deep antiquity, showing the indigenous development of Jyotisha Shastra in this country. And how did the colonial people get to know about it? There are at least 3 routes. I'm not going to talk about the earlier route, but the last route. The last route is direct transmissions that went, astronomy knowledge went to the Europeans. People like Cassini, Lee Gentle, Euler, Bailey, they encountered Indian astronomy and they thought it is very, very ancient and India is the source of all astronomy knowledge. But then when William Jones came on the scene, that's where the controversy started based on linguistic analysis, where they wanted to show why are Sanskrit, Latin, and Greek related. And so they postulated this Aryan invasion theory in 1500 BCE, thanks to which Vedic literature can't be more ancient than 1500 BCE. And that gave rise to a whole lot of distortions on Indian astronomy. So everybody has shown a red font here is against the antiquity of Indian astronomy. The people in the white font are open to this notion of antiquity of Indian astronomy. And the issue is, how old is it? Because linguistic theories are suggesting something that is simply not there in the Indian text. Indian texts are showing far greater antiquity. And the Western science, historians of science, they tie themselves into loops trying to understand why is it so ancient, Indian astronomy, what did they copy? And all these kind of issues come because of their foundational ideas on Aryan invasion theory. For example, Pingree. Pingree is a well-known name in the history of science, especially astronomy, and is a professor in New York universities. He has written outrageous things as far as Indian astronomy is concerned. For example, he says in this paper, in India, astronomers paid little attention to observation or to theory. He claims mathematical astronomy was introduced in India along with sciences of divination from the West, meaning Babylon. And he says it has come, and he even places Lagada to the 4th century BCE, completely ignoring the internal evidence of the text through which we can put it to 1400 BCE. And he also says an outrageous statement here: the preservation of Greek material is one of India's greatest contribution to the history of science. In other words, when Greek knowledge was lost thanks to the Christianization of the Roman Empire and the destruction of what they call pagan libraries, Europe went through dark ages. till the so-called Renaissance, Reformation, Age of Reason, and so on. And he claims if we want to understand what was in Greek astronomy, all we have to do is look at Indian astronomy because Indians have a true copy of Greeks. That is the kind of statement he's making over here. And we can see the hollowness of some of these claims later. So the lecture today is on cosmology itself. So we examine notions of cosmology and applications to astronomy and other things. If we look at material evidence, we find stone circles in different parts of India. This paper is from research done in Andhra Pradesh, where we find these stone circles. And these stone circles can be correlated along or aligned along with the vernal equinox, where the vernal equinox begins. So it appears to have been some kind of markers that say where will the sun be at the point of vernal equinox. So these are the kind of applications perhaps that stone circles were applied to. And this is a research paper that presents this idea and talks about it. We also have the Vedas, for example, the Nasadiya Suktam, which talks about creation, how creation came about, because cosmology is all about creation. How did creation come about? It speculates initially through a prediction or a hypothesis. Initially, there was nothing, no existence, no air, no heavens. What covered it? What was it? Who's keeping? And there was neither death nor immortality. There was only the one, Brahman, breathing windlessly, self-sustaining. There was no other. So here is our ancestors' attempt at trying to understand how did all these things come about? Was there a period of time when there was nothing? So they were predicting these things. Then they look at the scientific acumen. They correct themselves, caution. They say, after all, who knows? Who can say where it came, how it happened? Devas themselves are later than creation. So maybe even the creator does not know. So this is the kind of caution they have before they say something, saying, look, none of us know. We are trying to find the truth. That is what has come out in this particular verse. And we have many others like Hiranyagarbha Suktam, Devi Suktam. All of these things are our ancestors' way of trying to understand cosmology, the attributes of creation, and all of these kinds of things. We are all familiar with Srimad Bhagavatam, where we talk about Brahma and the Hindu cyclical universe. And we have a notion at some period of time, this kind of yuga model came into India, where we have a 4:3:2:1, with Kali Yuga starting at 432,000 years, everything adding up to 4.32 million years. And if you take 71 of this, we have a Manvantara. And if you take 14 of Manvantaras, you get a Kalpa, which is a day of Brahma. And the lifetime of Brahma is 100 years. And we're on the 51st year of the current Brahma. So this is the kind of time cycles that our ancestors were contemplating and thinking about for various purposes, whether it's accuracy in astronomy, calculations, or even otherwise. This is the kind of ideas they had. And the same thing pointed out over here. And we have in our astrophysics today, when we talk about cosmology, creation, there are people who say that there's an initial singularity, which we call a Big Bang. And from that, we have this expansion happening. And today we are here after 13.8 billion years with the modern galaxies and so on. So there are theories on how this inflation period was followed by when the first light come, when the first atomic particles get created, when the first stars form. All of these kind of ideas are present over here. But it's interesting to see the kind of timelines involved over here. For example, 4.32 billion years for a day of Brahma, maybe 4.32 for a similar nighttime, coming to almost 8.6 billion years. So our ancestors seem to have had the ballpark figure on the age of the universe, at least over here. And this is a model that has been contemplated in science today. It's called the Big Bounce model, a recurrent creation and destruction. For example, there is a notion that there's a pre-existing universe that collapsed due to perhaps gravity or some other forces that caused expansion to stop and collapsing. And that collapse led to a new singularity, and we have a new universe over here. So this is one such idea among many models that are proposed in astrophysics for the fate of the universe. And one such name is Roger Penrose, is an astrophysicist from Oxford University, who proposed that in the cosmic microwave background, he's found anomalies, up to 30 to 40 anomalies, which he proposes are the remnants of the black holes of the prior universe. It's a mind-bending concept, but there are some deep mathematics which uses something called conformal cyclic cosmology. It's not important for this talk to understand this, but there are several questions we can ask. If there was a big bang and a cosmic expansion, why is it that we don't see symmetry wherever we see in the universe? There should be symmetry. Otherwise, there's no symmetry. There was some initial condition. That initial condition led to matter and antimatter occurring in different portions of the universe, such that we see certain distributions of galaxies in different places. That is what we see today. Why is that? If there was uniform expansion, we don't expect that to happen. And so this is a concept of Vedic concept of vasana. Vasana is the imprints on our Atman from a previous janma. That's why we are driven to certain habits in this janma thanks to vasana. So there is a similar concept at work over here in the universe itself, that the universe expands depending on its past vasana, the black holes. That's what Roger Penrose is saying. And he got a Nobel Prize in 2020, not for this work exactly, but for other works in black hole. And he says an earlier universe can existed before the Big Bang and can still be observed today. Interesting to see how it's correlated with some of the notions that our ancestors were looking at. Then in Bhagavata Purana, we see the notion of what today we call multiverses, but our ancestors call them Brahmandas. They said there were innumerable Brahmandas. For example, here, when talking about the attributes of Vishnu, it's saying that there are so many universes, each 10 times greater than the previous one, innumerable Brahmandas beside this one. Although they are large, they are like atoms inside you. That's why you're called infinite or unlimited. And it again talks about countless universes compelled by the wheel of time to wander within you like particles of dust. This is amazing that our ancestors are able to abstract the notion of universes in this manner itself, saying that it's like dust and these are like atoms moving about in you. That is the kind of metaphor used here. In one more Purana, the Brahma Vaivarta Purana, we are seeing again where Vishnu wants to humble Indra. So he comes in the form of a Brahmana, and he points to a line of ants entering Indra's palace. And he says, each of those ants were an Indra in a different Brahmanda in a different period of time. In other words, he's trying to tell Indra, don't be too proud. There are so many Brahmandas, you cannot even count them. So the notion appears again and again. It's not an isolated text, but this notion comes repeatedly. In Bhagavatam, we also have the story of Kakudmi, the king, and his very beautiful daughter, Revati, who he could not find a match for. So he goes to Brahma to ask, have you made a match for my daughter? And Brahma is enjoying a Gandharva concert. So he waits for the concert to be over. And when he goes and tells Brahma why he's come, Brahma starts laughing and says, when you're waiting for the concert to be over, 27 Chaturyugas are over on Earth, coming to 116 million years. So this is something that we recognize today in physics. I'm not claiming our ancestors knew this, but we have the dilated time. Dilated time occurs either in the presence of a super heavy mass. That's where the space-time fabric is bent, and you can have dilated time over there. Or if you're traveling nearly at the speed of light, then too, time slows down for you. So these interesting concepts are even there in our stories. Maybe it's a coincidence, but it's intriguing to see that. Then Brihadaranyaka Upanishad, if you look at Yajnavalkya, so he's talking about cosmology, and the Rishi Gargi is challenging him, the court of King Janaka, and asking him about his knowledge. And she asks, so what is there on earth? He says everything on earth is wrapped in water. Water and air in the sky in the world of Gandharvas, the world of Aditya. In other words, he's talking about the layers out there which seem to parallel what we understand. So very interesting to see this idea of cosmology in Brihadaranyaka Upanishad. Then we have the notion of infinity. This is not trivial at all. This is not trivial at all, given that infinity was a scary thing for Abrahamic religions. Abrahamic religions, which believed that God created the world in 6 days and rested on the seventh day, created man in his image. So the notion of perfectness is built into it. The notion of a finite universe is built into it, because God is perfect. He did everything and is completed. There is no incompleteness. Infinity says it's not complete. It keeps increasing, whatever it is, whether it is time, size, space, whatever. So this notion was there in our very early ancestors. For example, in the Rig Veda itself, there is a metaphoric concept of unknown origin, open-ended universe. In other places, it talks about cosmic unity, again, symbolic and metaphoric. The Shatapatha Brahmana, it is talking about how the infinite Prajapati created universe from himself into dismembering to infinite parts. Brihadaranyaka Upanishad, we see the famous Purnamidam mantra over there, which is again talking about infinity very explicitly. So this way, we got different texts that clearly are talking about the notion of infinity. Then I will go on to talk about selected astronomy gems and various things. I'm just picking and choosing because these are all ideas of cosmology. These are ideas about our cosmos. And the reason why I'm rushing through this is I want to leave some time for Q&A in the end. Same Brihadaranyaka Upanishad, we find this amazing concept that Earth is suspended in space. The same Rishi Gargi is challenging Yajnavalkya and asking, Yajnavalkya, what is there above heaven and below the earth? And he's saying, oh Gargi, there is nothing pervaded by unmanifested ether. That is what he's saying over there. So basically it is space, unmanifested space. There's no form to it, just space above and below. In other words, Earth is suspended in space. Now, this is totally different from other civilizations who talked about the pillars of heaven, where heaven was thought to be a firmament on which stars are affixed, and there are pillars that hold them up, and Earth is flat. And these are the kind of notions that whether the Egyptians, Mesopotamians, and several other old civilizations had. But our ancestors seem to imagine that Earth is suspended in space. A truly amazing concept over here. Brihadaranyaka Upanishad also talks about gravity. Same Gargi is asking Yajnavalkya questions, and he calls it the rule of immutable. He says, under this mighty rule, the sun and moon are held in their position. Oh Gargi, heaven and earth maintain their position. In other words, all planet stars are all there thanks to this gravity. Even time, he says, muhurtas, days, nights, fortnight, everything is held in the respective place. Even the rivers, some flow east, some flow west, thanks to this. Today we know that gravity, it affects time through time dilation. We talked about that already. Gravity is a force that causes rivers to flow. Gravity is a force that keeps planets in orbit. We understand that through gravitational theory, but we see that this has already been expressed by Yajnavalkya in a very early period of time. We're seeing these things. Even hints of heliocentrism. People might scoff when they hear this, but then we see in the same Shatapatha Brahmana, we have this notion that the sun strings these words to himself on a thread. Now the thread is the same as wind. So in other words, it's saying the sun has strung the planets to himself on a thread. That is what it says. In Aitreya Brahmana, we are seeing that the sun never sets nor rises. When people think the sun is setting, it is not so. It just makes night on waters below and day on this side. It's a clear understanding, very clear understanding at the time of Rig Veda, Aitreya Brahmana itself, that this is what it is. The sun is not setting or rising. It is where it is. It is just this is what is happening. So very intriguing to see these things. And there's one more observation to make over here. And that observation is, as an engineer, I say that there's a causal hypothesis. If there is motion somewhere, there must be a prime mover. There must be a cause and effect behavior in the universe. And our ancestors have understood this. They were wondering, why are the planets moving? What is causing them to move? Those kind of scientific questions they're asking. And they speculate it's pushed around by a wind that is tied to the sun. Now, it is not important to say, hey, and laugh at them saying they made mistakes in mythology and all those kind of things. But see how it has been done over here. Instead of the Abrahamic systems that said God's will, that's why it happens, or God willed it, that's why it's happening that way. They were going after cause and effect. In other words, they were using Vaisheshika. They were trying to see Pratyaksha Anumana, trying to see through my observations and through my inference, I'll try to get an understanding of what is going on over here. We see that repeatedly in the Indian works, sometimes embedded in stories, sometimes in metaphoric content. But if we read it deeply, we understand from our present day science, this is what they were doing. It's cause and effect behavior. That is what they're doing over here, rather than saying something else. They even understood the phases of the moon. For example, in the Aitreya Brahmana, we are seeing the moon enters the sun on the new moon day, or the moon is born of the sun. A clear understanding that when the sun and the moon are in the same longitude, then we cannot see the moon's Amavasya. And as it goes away, then we see the various phases of the moon, what we call tithis. And another place where it says the moon receives light from the sun in the Taittiriya Samhita. We are seeing that. This is from S.B. Dikshit's works on Bharatiya Jyotish Shastra. And we are seeing also that the sun rays, that description of sun rays is based upon the 7 horses that draw it, clearly pointing out to the fact that the sun rays are composed of these colors over here. And the cause of seasons and wind, that is also over here. It is the wind is because of the sun, born of the sun. It generates the directions and controls the seasons. These are things that we see in Aitreya Brahmana, the Rig Veda Samhita, and other works. So there was a sampling, a very quick sampling to show that cosmology was understood in various categories of literature, whether it is in the Brahmanas, whether it is in the Samhitas, Aranyakas, Upanishads. It is scattered over there, but what is there is amazing. Amazing that our ancestors are able to be so scientific in the way they were making their statements and so on, at a time when the rest of the world, they were not. They were simply not there in this kind of thinking. Then we have another category where there are stories, where very ancient knowledge is encoded in the metaphor of stories. And these were promptly dismissed by the Western historians, especially the missionaries, to show how superstitious Indians are, how much of mythology they have in their religion, how much nonsense is there. But really, if you have the key to unlock the wisdom in that story, then the wisdom becomes apparent. If you don't have the key to unlock the metaphor, then it remains at the pedestrian level understanding, where you call it a mythology. So if somebody says this is a mythology, it's an admission of their own ignorance, that they haven't understood what the metaphor is. And we got so many stories. I'm not going to go into this. I have several talks on that. For example, Chandra married the 27 daughters of King Daksha. This is talking about the nakshatras. It is referencing the sidereal month of 27.3 days, when the moon comes back to the same background star. That's what it's talking about. Then when it says Chandra visited one wife each day, it is basically the fact that moon covers 13 and 1/3 degrees in a 24-hour period. Today at 8 o'clock at night, if the moon is somewhere overhead of you, then tomorrow at 8 o'clock at night, you see where the moon is, it will have fallen behind by 13 and 1/3 degrees. This is what they meant by this. And the fact that Chandra loved Rohini the most, I've shown that is related to the occultation phenomena. Then Chandra getting cursed by King Daksha and the alleviation of the curse by Mahadeva to waxing and waning. This refers to the 29.5 days synodic month. The story of Dhruva, that refers to a pole star, and in some places also in precision. The story of Yayati, I've shown in another talk, it refers to the Andromeda galaxy. The Surya story, this is referencing the memory of a massive solar flare that occurred around 9,000 years ago. I've got talks that cover all of these stories. If you're interested in them, please do take a look at it. So this is the way that knowledge is encoded into stories for mass communication rather than a scholarly communication. And the Indian astronomy model, we know, was nakshatras and Rashi. I've talked about this extensively in the past. And we also had the lunar month. If, for example, the full moon occurs at Chitra Masa, we have the Chaitra Masa, Chitra Nakshatra, we have the Chaitra Masa there. In northern India, it was a Paurnami, the full moon. Southern India, it is a Amavasya, the new moon. So we have a 15-day offset between these months over here. And to track the movement of the sun into various Shankrantis, we had the Rashi model. Rashi model was 30 degrees division of the sky, and these are the familiar Rashis that we have. So we have truly a lunisolar calendar. And this is a listing of the nakshatras in the various, two ancient books, Vedanga Jyotisha, Surya Siddhanta, and the Western identification of the principal star. what these nakshatras are. And if we take a look at the nakshatra names in Sanskritam, Telugu, Kannada, Hindi, Gujarati, Marathi, Tamil, Malayalam, we are seeing the names are the same throughout India. It is not something related only to Haryana or only to Punjab and those areas, but we are seeing the same names everywhere with minor, very minor variations, regional variations. For example, the Ardra Nakshatra becomes the Tiruvadirai in Tamil and Malayalam, or the Ashlesha becomes the Ailiam. So this is showing the antiquity of the nakshatra model, that it is so ancient that it's adopted throughout the country, it's diffused throughout the country. We also have regional differences in the names also. But again, if you look at the etymology of these names, they mean the same thing. They actually mean the same. How did our ancestors track the nakshatras? How did our ancestors go and tell somebody that Kritika is over there, Rohini is over there? How do you do that? Because when the sun goes down, you see a nakshatra there and say, hey, it was there in the eastern sky and they point over there. That is not true, because along the Earth's rotation, 2 or 3 hours later, that nakshatra had moved much, much ahead. So how would you communicate to somebody where the nakshatras are? Well, Indians had this coordinate system of the skies, very similar to what we have today, latitudes and longitudes for terrestrial points. We had a sky map that was based on something we call an ecliptic coordinate system. In the ecliptic coordinate system, the apparent path of the sun, as it appears to go around the sun, around the Earth, that was a cutting plane. It divides the celestial sphere into northern half and southern half. And if it was a nakshatra over here, they would measure the distance of the ecliptic and the distance of the longitude. The longitude aligns with the vernal equinox. It is a sidereal measurement. I'll talk about this a little later. But this is the way they kept track of different celestial bodies. So the list of nakshatras starts with the New Year. New Year in India has always been vernal equinox. So at vernal equinox, what was that first nakshatra over there? That heads the list. Indians, like I said, use ecliptic coordinate system, and a term called Swabhoga that mark the longitudinal position from the previous window. I'll explain this in just a minute. And we also see that because of something called precession, which I'll explain a little later, the nakshatra at the vernal equinox changes over thousands of years. Each time it changed, we have evidence that our ancestors were recomputing new coordinate systems for the nakshatras. Every time the reference changed, this was done. And to give you some text evidences, you can go to Surya Siddhanta. In the version that I have, Burgess translation, which is chapter 8, where the position of the nakshatras is called Bha over here in minutes, and it's given. And if I go to the next slide over here, we are seeing, for example, at 8th chapter, numbers like 48, 40, 65, 57, these kind of numbers are given. And these are referencing, in the version of Surya Siddhanta we have, the first nakshatra is Ashwini, dating back to approximately 600 BCE, when that was the vernal equinox point. So the 48 refers to Ashwini. And if you multiply this by 10, you get arc minutes, 480 minutes, which can convert to degrees and minutes. So this says the zero longitude is vernal equinox. So it spans 13 and 1/3 degrees, or 13 degrees, 20 minutes. So 0 to 13 degrees, 20 minutes is Ashwini. And within this interval, it is located at 8 degrees. That is what is referencing to. And the next one, Bharani, the number is 40, which comes to 6 degrees, 40 minutes. So its span is 13 degrees, 20 minutes to 26, the next window. In that window, where is this located? So this is the way our ancestors have communicated in a very mathematical, scientific way on observing the nakshatras and telling you how to locate the coordinate longitude in the skies. That is what you're seeing here. Okay, moving on in cosmology, what are the things our ancestors saw? A whole lot of astronomical phenomena. For example, there is Rishi Atri. He observed a solar eclipse, and you'll say, big deal. We all see solar eclipses in our lifetime, at least one we see. So why is Atri alone immortalized in the Rig Veda for having seen this particular eclipse? And there are many people who are trying to date this eclipse too. Some who say it happened in 4202 BC or maybe in 3800 BC and so on. But that doesn't matter. It's an ancient period of time. And the translations are interesting. It comes to a reference to Turiyena Brahmana. And this is a very interesting thing that Tilak, Balagangadhar Tilak, called out. And I'll show what he meant in a slide or two. But the point is, when Rishi Atri's eclipses mentioned, it references Rahu and Ketu. This again led the missionaries to say how superstitious Indians are. They didn't know what an eclipse is. They thought the demon is following the sun. But it required Aryabhatta to explain what is Rahu and Ketu. Aryabhatta saw the plane of the moon's orbit is offset from the ecliptic, which is the apparent path of the sun, by 5 degrees. Because of that, if we want to have a solar eclipse, then these two planes must coincide. When it coincides, then we have a solar eclipse. Or on the other side, you have a lunar eclipse window. So he referred to the rising and falling, ascending and descending nodes as Rahu and Ketu. So he gave the mathematical meaning for what is Rahu and Ketu by doing this in Aryabhatiya, where he's also given the distance, the shadow, length of Earth's shadow, length of Moon's shadow, the eclipse phenomena, everything is given by Aryabhatta. So Tilak, he's referencing Turiyena Brahmana to mean by means of the Turiya, which is saying that it's a yantra that has been used. It is mentioned the Siddhanta Shiromani, for example, there's more reference to that. And it is basically, it is some kind of a quadrant. It's by the quadrant is how they have referenced Atri. Why is all this important? The idea is that if this is the way eclipses happen, there is an angular relationship between the sun and the moon that will allow us to predict that the next Amavasya, we might have a solar eclipse, if you understand the phenomena. But you need to measure the longitudes. You need to measure these things. So it looks like Atri has measured with some device, he's measured the angles, he was able to predict. It reveals an understanding of the phenomena, how eclipses occur. It reveals that he had an instrument to measure the celestial angles and predictive capability. He was able to say 5 days later, when Amavasya happens, you'll have an eclipse, it'll occur for this amount of time. So these are the things that falling out from here. And we think that is why he was immortalized in the Rig Veda. And this is a sample of the Turiyena Yantra. The modern quadrant looks like this. And this is in the Islamic world. This is how they designed a quadrant along with this plumber's line. You can think of it to measure this angle, like a protractor in the sky. And in China and in medieval Europe, they use these kind of things. And India too had these kind of instruments with a string that you can see to measure the angle. Indians also observe transits. Transits are called Grahayuti. And typically it happens to Venus and Mercury, the inner planets, when they go across the face of the sun. This is a photograph that I took in 2016 when Mercury, this tiny dot that you see here, this is Mercury, when it goes across the face of the sun. So Indians had observed this. This is very important because when they had their models of planetary movement, they'll know when will that longitude between Mercury and Venus and the sun go to zero. And they could actually, if they were in a position to observe it, they can say, yes, the error is so much, and they can correct their models. So it allowed them to do measurement, first prediction, then measurement, and refine the parameters governing those equations. It is exactly what we do today in modern day curve fitting, calibration. This is what we do. When we take our model, we see the model does not work, we measure it, and we try to have a fitting towards that. And there is evidence for this. Vedvirarya has pointed out that Mallikarjuna Suri from Andhra Pradesh, he has talked about that. He's talked about Mercury and Venus, how they are always illuminated because they are nearer to the sun. And Kamalakara in Maharashtra, how amazingly, he's even said that they look like holes on the sun. And this is amazing because how would you observe with the naked eye? In order to take this, I had to use a solar filter on the telescope and then take this picture. So I'm imagining that maybe in the early morning or late evening, when there's dawn or twilight, that is when we can see the sun as an orange ball with the naked eye. And perhaps then they were able to somehow see Venus and Mercury going across the face of the sun. But that's what he says. They look like holes in the sun. Indians also observed planetary conjunctions. They refer to them as yud, for example. The conjunction in Surya Siddhanta talks about that, how to determine the longitudes and when conjunctions will happen. Occultations, already talked about that. Chandra loving Rohini more than his other wives is related to the notion when the moon covers a nakshatra from our perspective, that is referred to as a lunar occultation. And Indians observed this in addition. Comets, they were called Dhumaketu. Many references in India, Rig Veda, Ramayana, Itihasas, and several works, including Sangamira Tamil works that are referring to comets and Dhumaketu. And Professor Iyengar has worked a lot on this. He's, for example, compiled Varamira's list with 100 comets in Brihat Samhita, giving several names, Chayaketu, Dhumaketu, and others based upon their appearance. He's even categorized them based on their appearance, their color, their tail, whether they have one tail, two tails, and all these kind of things. So this kind of a categorization is perhaps one of the world's earliest catalog of comets, their types, their shape, and other such things. This is what we have over here. And also, Varamira says, of course, he's not observed 100 comets in his lifetime. He says that he used sources from earlier sources to compile the catalog. So clearly showing that observational record has been maintained in works that we might have lost today, but Varamira had access to some of them, and he's written about these things. Then we have calendars. Calendars were the application, killer application for the mathematical astronomy to keep track of the passage of time. And some of the basics that we have is this Nirayana and the Sayana. There's an animation that should play over here. If it works, let me click it. Okay, I'm not able to get this animation to work, but it has showed you what is Nirayana and Sayana. So Nirayana refers to, for example, the passage of a day. When the Earth is going around the sun, it's also rotating. That rotation, if I start out with, let's say at some point in the rotation, Earth is looking at, let us say, Rohini in the evening hours. When it comes back to Rohini after a period of time, close to 24 hours, that is called a sidereal day or a Nirayana. The Sayana would have to point to the sun itself coming back to the certain point. And that takes a little extra time. It's a little confusing that I wish that animation had worked and could have shown you that one. But basically, that's what it refers to as Nirayana and Sayana. And again, where are the sources for these things? Vedanga Jyotisha. It's mostly Nirayana, meaning that referring to a star in the background. That is a reference for most of the works. It also references solstices. That shows seasonal awareness, that is Sayana, even though it's not explicit. Surya Siddhanta has got both Sayana and Nirayana values and explicit calculations of precision. I'll show you this a little later. Aryabhatta, mostly Nirayana, but then he's aware of precision, which he called Ayana Chalana. But his followers, they included seasonal corrections, that is, Bija is clearly a Sayana. And later Siddhantic astronomers, they offered both Sayana and Nirayana tables. And now the key issue is, why were they using it? Yes, there were many applications for Sayana astronomy and Nirayana astronomy for various rituals, keeping calendar, and other such things. But it led to a controversy. The controversy was once again started by the Western historians of science. They claimed Indians did not know about precession of equinox. They learned about this from the Greeks, and that's how they got to know about it, but they did not know it. But if Indians were using Sayana astronomy, they clearly had an understanding of precession of equinox. So let me go to that. This axial precession is one of the heights of accomplishment of our ancient ancestors. So we have something called Milankovitch cycle. This animation shows you that Earth, in addition to rotation, 24 hours, revolution, 365.24 days, it has this orbital cycle changes, where it goes from circular to elliptical in 100,000 years, or the axis of rotation, where the Earth is pointing to the sky as it is rotating. That is tracing a slow circle in the sky called axial precession that takes 26,000 years to complete. or change in obliquity taking 41,000 years. This cycle is very important for us because our ancestors always said at vernal equinox, what was the nakshatra over there? Or at a solstice point, what was the nakshatra over there? Again, please don't annotate. Now, over thousands of years, that reference point can change because of this movement. That is why we need to understand this very, very carefully and see how Indians had used this phenomena. Here is an example of David Pingree in this paper. He is saying, Varamira, he recognized some statement of Lagada that clearly understands that there is some kind of precision information. But then he's saying, it is not unreasonable. Look at the language in a scientific paper. It is not unreasonable to suppose the idea of trepidation of precision was introduced in India by the Greeks, though the parameters chosen by the Indians are their own. So clearly we have over here, he's uncertain about it, but he's made such a kind of assertion anyway, saying that Indians have copied the idea of precision from the Greeks. I will give you some evidences now to disprove whatever Pingree was saying. We have textual evidence of precision itself in the Vishnu Purana, Book 1, Chapter 12, where Vishnu is telling Dhruva, I will give you a station in the sky above all the worlds and all these planets and the Saptarishis, everybody will go in pradakshina around you. That's what he's saying. And this part of this verse is specifying Dhruva as a pole star. But then he's saying, you're not there permanently. You'll only be given the duration of one kalpa. That is what he's saying. By assigning a fixed period to Dhruva, it is clear that it is temporary. It will change. You won't be Dhruva forever. Where the earth is pointing to will not be Dhruva forever, right? So that idea is there in the Vishnu Purana itself. And by the way, he also says, your mother, Sumati, she will abide near you for a similar term, meaning that where Dhruva is, there's also going to be a companion star. But today, Polaris is close to the pole, north celestial pole, but there's no companion star over there. To find out when there's a companion star, I have shown in my talks that you have to go back to 2800 BCE, almost 5,000 years ago. That is when Thuban was the pole star, and next to Thuban, we find a small companion star. So when the Vishnu Purana was written or compiled around that time, Vedavyasa perhaps, so we are seeing that this is the state of the sky, the pole star. And around that time itself, it is known that Dhruva's reign is temporary, it's not permanent. Then Professor Iyengar has compiled some more information. For example, in Brahmanda Purana, it is talking about giving the metaphor of a potter's wheel, how the potter's wheel at the navel point, it moves very slowly, right? At the center, the wheel is spinning very slowly. The circumference is going very, very fast. So he's giving an analogy of Dhruva, why Dhruva is rotating. So that is known over there. In Vedanga Jyotisha itself, it is talking about the sun goes north without reaching Shravana, or goes south without reaching Ashlesha. It causes great fear. In other words, it used to go there during the Uttarayana, Dakshinayana, but if it does not reach that point, why will it not reach that point? Because of precision. So there's a reference to that there itself in a 1400 BCE text. Then in this Maitrayani Upanishad, this king is posing a question to this rishi over here and is asking, why is Dhruva drifting? The North Star, understood by us as fixed, has changed its position. So clearly it is saying the drifting of a pole star is consistent. Professor Iyengar is saying the date of 1500 BCE, but the point is that there is observation, clear observation that the pole star is not fixed and is changing over time. And because Pingree has suggested that Indians are rather asserted that Indians have copied it from Greeks, we can see where did the Greeks even understand about this. We go to Hipparchus, 120 BCE, who benefited from the library of Alexandria to learn about things. His works have not survived. But Ptolemy, who lived in 150 current era in Alexandria, he is quoting Hipparchus, saying that the solstices and equinox move backwards not less than 100th part of a degree per annum. In other words, 36,000 years to complete one cycle. And this is there in this research paper, you can see this. Then we know from Professor Iyengar's work again, he's talking about Parashara and Garga, how Panini is referring to them. Therefore, they lived before Panini, much before Panini. In fact, he dates them to about 1400 BC, same period as Vedanga Jyotisha. And we also see in this work P.V. Kane, who's saying that in History of Dharma Shastras, he is talking about how Vritigarga is talking about the 7 rishis turned from nakshatra to nakshatra, remaining 100 years in each of these 27 constellations, in each nakshatra for 100 years. And Professor Abhyankar has interpreted this as 1 degree for 100 years, which comes to 36,000 years, much before Hipparchus lived. Hipparchus is quoted the same figure as Vritigarga of this figure. We know Alexander, he copied texts for his teacher Aristotle, and that formed a conduit for knowledge transfer from India to Greece. So this notion of who copied from whom has to be revisited, and we can show with evidence that it's the Greeks who copied this. In fact, in Surya Siddhanta, we are seeing the circle of nakshatras rotate 600 times in a Chaturayuga. It's talking about a sine wave. It goes from 0 to 27 degrees, comes back to 0, minus 27, back to this. And to cut a long story short, this can be interpreted as in a yuga of 4.32 million years, it completes 600 revolutions. Therefore, 7,200 years per revolution over here, called Ayana Chalana. So if you take 600 revolutions, multiply by 27 degrees, 4 segments, 1, 2, 3, 4 segments, multiply by 60 to convert to minutes, multiply by 60 to convert to seconds, divide by time, 4.32 million years, we get 54 arc seconds per year. That is the Ayana Chalana in Surya Siddhanta. How much precision is changing. It's an amazingly small amount that it changes, but our ancestors are able to do it. And you can also see other civilizations. What did they know about this? For example, Surya Siddhanta, I'm not putting a date on it. The estimate is 54 arc seconds in a year. Vritigarga, whether it is before Panini, after Panini, I'll take conservatively 500 BC, 36 arc seconds a year, or 36,000 years to complete a cycle. Same figure quoted by Hipparchus in 120 BCE. In China, 72 arc seconds a year. Aryabhatta, 48 arc seconds. 54 arc seconds is an overestimate. The true figure is 50.2 arc seconds, a modern figure. 54 is an overestimate. Aryabhatta is an underestimate, but the error is smaller. The Arabs copied Surya Siddhanta directly, right after the Bin Qasim's invasion. So Al-Batani quotes the same figure as Surya Siddhanta, 54 arc seconds. But this was refined in India over time, showing that it is not fixed in time like Shastras, but our scientists were continuously trying to refine it, making it better and better and better. By the time we come to Patani Samanta Chandrasekhar in 1900 current era, he's got a figure of 49.179 arc seconds using naked eye observations, not using telescopes. He was able to do these things. Okay, we go back to calendars. We know we have solar months, we got lunar months. Won't go into detail over there. 5,000 years of time constants, times for 1 muhurta, 48 minutes, 30 muhurtas, 1 ahoratrams, 30 ahoratrams, 1 masa, 2 masas, 1 ritu of 60-day season, 3 ritus is 1 ayanam, 2 ayanams is 1 varsha of 360 days. And the shortfall was covered by something called Atiratra sacrifice for 4.5 to 6 days, according to Professor Abhyankar. In Atharva Veda, it says the rishi called Rohita, he created the Adhika Masa. Every 2 years or so, when an additional month was inserted, intercalary month was inserted, so that it will average out to the same 365.24 days. And the Panchanga, a 5-dimensional measure of time, with Muhurta as the basic unit over here, we are seeing Nakshatra, sidereal measurement, Tithi, synodic measurement, Vara, Yoga, Karana, Tithi by 2. And the day begins at sunrise, and these things are all determined at that particular time. I'm not going any deeper into this. We also had weekdays. These are the typical weekdays. For example, Ravi for the sun, Soma for the moon. So each celestial body was given a day over here. And many people have speculated, where did these things come from? Europeans say it came from the Nordic identities, deities. But then we can show a long tradition in India itself. Aryabhatta is talking about this. Surya Siddhanta is talking about this. And there are several people who are trying to describe why the particular ordering of the days of the week has happened. But we can see Another very intriguing evidence that you don't normally see. And this comes the order in which the planets are given in Surya Siddhanta. When it talks about the revolution period, Sun comes first, then comes Moon, then Mars, then Mercury, then Jupiter, then Venus, then Saturn. Why the strange way? This is the exact days of the week: Sunday, Monday, Tuesday, Wednesday. It comes over there. We are finding that repeated in the Surya Siddhanta itself, in the ordering in which these things are given. That's all I want to say about the days of the week. And I also want to point out that there are several non-ideal calendar elements. Now, calendars, each of these things can be determined based on ideal behavior. Ideal behavior means uniform behavior. For example, the nakshatra will change every 13 and 1/3 degrees, right? That is uniform, assuming it's all uniform partitions over there. Tithi will change every 12-degree change in sun and moon's longitude. Again, uniform assumption. Is it true? This is ideal according to textbook formula. But then our ancestors knew better, right? So they had non-ideal ways of doing things. For example, if you take the Drik Panchanga, you might see, for example, over here, I have highlighted two of these things. 20th and 21st of May 2024, both had the same Tithi, Trayodashi over here. And over here, you find the Chaturthi and the Shashti over here. By skipping something over here, Chaturthi, it goes to Shashti, skipping something over here. So you wonder, why are these non-idealities? So Drik Panchanga was by actual observations, not by mean calculation. So there's a difference between the observational and the calculated Tithi. And that could be the reason why we are seeing these differences. I'd like to talk to you a little bit about this non-ideality, because hiding behind it is an enormous wealth of knowledge of our ancestors. Now, a little bit on physics. We know that if you take a pendulum and swing it, when it goes to the highest point over here, the velocity is zero. We learn in high school, right? Potential energy is highest, kinetic energy is zero. When it comes here, its fastest velocity is highest over here, because it has been pulled by the Earth. You can think of Earth's gravity concentrated at this 90-degree angle. It's pulling this, and that's why the speed is highest. Again, becomes slow here. A similar phenomena happens in our orbits also. If you take this as the Earth and this as the Sun, what we see is, as the Earth's orbit nears the Sun, what we call perihelion, it speeds up. As it goes further away from the Sun, it slows down, called aphelion. Same thing for the Moon and Earth. If this is the Moon and this is the Earth, then the furthest point is called apogee, where the Moon slows down. And as it comes closer to the Earth, because of Earth's gravity, it speeds up. It's called perigee. And we find that our ancestors have accounted for these things. So by accounting for this elliptical orbits, literally, indirectly, based upon what we can see, the evidence I'm going to show you, 2000 years before Kepler, our ancestors have already accounted for many of these things. For example, the non-idealities that I talked about, if we take a look at some of the parameters given by Aryabhatta, he's talking how many revolutions per Mahayuga for the sun, moon, and all these planets. But for the moon, we are seeing something called lunar apogee and lunar node, ascending node. And he has given some figures over here, and Ptolemy and others, we don't worry about that, but they have also given similar kind of figures. And what does that mean? So we are seeing that because of this, what I just told you, the perigee and the apogee, where this perigee and apogee happens is not constant. That point is also rotating about the Earth. That's what I tried to show in this picture over here. If it is happening here, later on, this perigee is going to be over here. It later on will be somewhere over here. And this completes an entire rotation. And this is called the orbital period of apogee of the moon. And that is what our ancestors were trying to determine. I'm not going to read all these things, but that is one non-ideal behavior. One more non-ideal behavior is the ascending node of the moon. This ascending node also undergoes a rotation about the Earth, and this also takes a certain period of time, the 6,791 days to complete one complete cycle. What are we saying? We are seeing that there are non-idealities in the moon's orbit around the Earth. And this immediately tells us common sense the nakshatra model could be varying, the tithi model could be varying. Because tithi is varying, the yoga, karana, everything's got to be non-uniform. Things are varying. Immediately we understand these things. And I'll show you that in a minute. And the time was measured in India using water clocks and things like that. We had various measures like Gatikas, Palas, Vipalas. 2 Gatikas makes 1 Muhurta of 48 minutes. So each Gatika is 24 minutes approximately. But we had several of these measures to measure things, even up to 0.4 of a second, 0.006 of a second. The Tithi duration. We find that our ancestors have measured this thing such a way that the Gatikas, Palas, or Vipala, or hours, minutes, and seconds. The average is 23 hours, 37 minutes. The greatest length, 26 hours, 6 minutes for the Tithi. And the least length, 21 hours, 34 minutes. So clear understanding is there that because the sun and the moon are in various speeds as it goes through different quadrants, apogee and perigee, because of that, they have shown these things. Even the size of the month, Arya Siddhanta, Surya Siddhanta, evidence is there. These are the solar months, Mesha, Vrishava, all these things. And days, Gatikas, Palas, or days, hours, minutes, seconds. And here too, we are seeing that this Mesha Rashi is 30 days, 31 days, 31 days, 14 hours, 30 days, 29 days. Once again, 30 days. So as you can see, as it comes closer to the earth, it is speeding up. As it comes closer to the sun, earth comes closer to the sun, speeding up. As it's going away, slowing down. So clearly in these early works itself, these things are known. And the nakshatra and the yoga duration, once again, I'm not going to read out all these things, but you can see the mean, greatest, and the least. The length of the moon's nakshatra is not 24-hour period like I said earlier. The biggest one is 26 hours, 32 minutes. Smallest one is 22 hours, 22 minutes. And similarly for the tithi. And even the nakshatras, the nakshatra duration is not the same. In fact, Brahmagupta and Bhaskaracharya, they say there's a system that was followed by Garga, in which 6 nakshatras, Bharani, Ardra, and others, have half the normal length. Rohini, Punarvashi, and others have 1.5 times the length. Remaining 15 have normal length. This is what we see over here. If it was equal spacing, everything is 13 and 1/3 degrees, right? Each of these nakshatras. In the Garga system, this is what we are seeing. At 18 degrees, 20, 38, 53, very non-uniform. Similarly, in the Brahma Siddhanta system, we are seeing a non-uniform referencing over here. So this is showing to us that non-idealities are also taken care of by our ancestors. And coming to the last topic over here, the tracking of planets. There are 2 things to talk about. One is the mean position of planet. I'll first talk about that. By the way, I was called an astrophotographer. So here are some of the photographs I've taken in 2018 of Jupiter, Moon during an eclipse, Saturn, and Mars with a polar ice cap shown over here. So again, David Pingree, the author of Confusion, he says in the recovery of Greek astronomy from India, he says Aryabhatta did not observe. Then he says, how did he arrive at mean motion that is correct for his time? Answer is extremely simple according to Pingree. He's saying he used Greek tables to compute the longitude for a specific time. In some other place, he's saying that planets appear in what he calls inverted quotes, astrological sense. I don't know what that means. And he's saying that it was used in a strange way, but they did not know a method of computing planetary positions. That is what he's saying. Where is the evidence for these works? He's made these speculations. First of all, we'll talk about Parashara. His lineage is Vashishta, Shakti, Parashara to Vyasa. That's the lineage. And Professor Iyengar, first of all, he points out that he lived in the time frame of Vedanga Jyotisha around 1400 BCE. Then the works of Parashara have not survived, but commentaries, Bhashyas by Utpala and Balalasena, that has survived, and they have referenced extensively to Parashara's works. That is how we know about what Parashara's Samhita had. And he's saying that he's talking about the seasons. I'll skip that, skip this over here. About Jupiter. He's saying Jupiter travels 2.25 nakshatras in 1 year, leading to good crops. This is a mathematical data point. It is saying that it is a 12-year sidereal cycle. 2.25 nakshatras in 1 year. You can extrapolate how for the 27 nakshatras, how long it takes? Approximately 12 years. That is what we find over here. Another place for Saturn is saying Saturn travels to the 27 nakshatras in 28 years. So Parashara is 28 years, modern figure is 29.4 years. Now, the inner planets, Venus and Mercury, are not easy because sometimes appear in the evening time, sometimes the daytime, in the morning time. So it's not easy to track these things. But he sees how many routes are there. If you see it in the evening, how many places can you see it? And those are the routes. And he's saying for how many days there'll be 55, 60, and all these things. If you add up all these routes that he has said, Parashara's period for Venus is 591 days. The modern figure is 584 days. He did not get Mercury right because Mercury is very, very difficult to model over here. Even with our everyday observations, we can't track Mercury easily because it rises for a short time before sunrise and for a short time after sunset only because it is so close to the sun. So the point is, Parashara's time itself, observational astronomy was followed. Through that is how we got to know about these things. Then you go to Surya Siddhanta. Surya Siddhanta, I already pointed this out to you. In a Chatur Yuga, how many revolutions of the sun? 4 million, so on. How many of the moon? 57 million. How many of Mars? 2 million. How many of Jupiter, Mercury? All this data is given over here. This is the only data or Siddhanta astronomers needed to mug up to understand. Because with this data, they could do wonders that no European astronomers could match, even the 17th, 18th centuries. Now, this is what they said, right? In a Chatur Yuga, how many revolutions are there of each of these things? From that, we can compute every day how much does it move in a uniform motion, mean daily motion. How many revolutions of Mahayuga divided by number of days in Mahayuga, multiply by 360 degrees, you'll get this. So the sun traverses nearly 1 degree, 59 minutes, 8 seconds, and others. Mercury travels 4 degrees, 5 minutes in a day. Venus, 1 degree. So on. And the moon, 13 degrees. We already know these things, right? So this is the data which we use for other things. So the term that Indians used is Ahargana. Ahargana is used to estimate the mean position of planets with respect to a given epoch. If you know how many days have elapsed in that particular epoch, then that is what is called Ahargana. That is a starting point. For example, I can say today's date is 24th August 2025. How many days have elapsed since the start of Kali Yuga? Kali Yuga is February 18, 3102 BC. If I can calculate that, then that is called Ahargana. That is a starting point. Then given the mean motion, then given at Kali Yuga time, where was Mars, for example? If I know that, then I can compute today where is it going to be with a simple formula, right? So the mean position of a celestial body at the present day, first I must find out the 0th position. At the beginning of Kali Yuga, where was a planet? What is Ahargana? How many days have elapsed from Kali Yuga till the present day? What is a daily mean motion? Where do you get daily mean motion? From the tables in Surya Siddhanta. This is what gives you that, right? So we know that. So if you do this multiplication, very simple computation, you can say what is the longitude at which you'll find the Mars, assuming uniform motion, daily mean motion. And every Siddhanta astronomer used beginning of Kali Yuga, starting at this time frame for their calculations. So, for example, we got these various people, Aryabhatta to Bhaskara II, they're talking about the sun. How many revolutions in a Chatur Yuga? Yes, sun is understood, 4.32 million years. Chandra, apogee, ascending nodes, and other such things. And daily mean motion, according to these various people, Surya Siddhanta, Siddhanta Shiromani, modern astronomy, Brahmagupta's works, Khandakadyaka, and others. What was the 0 reference point? Like I said, the 0 reference point was beginning of Kali Yuga. In Siddhanta Shiromani, this was the starting point. In Surya Siddhanta, they're all at 0. They're all clustered at 0 in the Revati Nakshatra. This is the beginning of Kali Yuga that I can say. Surya Siddhanta implicitly says all clustered at 0. With that reference point, we don't even have to worry about the starting point. You can straight away compute what the mean position would be today. Indians also did Desantara correction for the mean position. This means a longitudinal correction. Supposing they get their numbers with respect to Ujjain. Ujjain was a reference longitude. But if I'm in West Bengal, then there's a difference between Ujjain and West Bengal. So if I know the local longitudes, I can make the Desantara correction. They were doing these kind of corrections in addition. Unfortunately, because of non-ideality, the mean motion won't do. How do they compute the true position? The true position was done using the epicycle model. I am the last point of my talk. I'll stop after this. So in the epicycle model, the Earth was at the center and the heavenly bodies were going around the Earth. There's a big circle on which the mean motion was. The mean motion I just talked to you about is found on this big circle. But there is the planet, the actual true position is on a smaller circle whose center is on this. It's called an epicycle. So it moves in the opposite direction, second cycle opposite direction. They move at the same speed. And the mean position is found in the bigger circle. The true position is over here. And the parameters that describe this one are the radius of the deferent. What is the radius here? What is the radius of the epicycle? What is the speed of the planet? What is the speed of the epicycle? So these are the things through which they could get a great number of behaviors for the mathematical model. So they could model all the planets, Mercury, Jupiter, Saturn, everything, including retrograde movements. They could model all of those things because remember, you're observing from the Earth. So there's a retrograde movement. They could model all those things mathematically with this kind of a model. I don't think this animation is going to work. My apologies. I moved to a different computer than my home computer, and I don't think I copied these files to do that. Apologies for that. So I'm not going to go to math over here. It's called Mandafala. So the Indians had something called Manda, and for the apogee, basically, and they had Shigra, which is the fast epicycle. So they had ways to do these things. I'm not going to read the mathematics, but the point is, in order to do this, they required something called R sine of a quadrant of a certain particular thing. So to do that, in Surya Siddhanta, we find difference tables using which you can compute the trigonometric sine function. You can compute in 3.25 degrees, I think. It goes all the way from that to a certain number. So trigonometry was born because of the need to compute the true position. And the algebra for this was well understood by ancient Indians. And they were doing all these computations to do that. More than that, they had something called pulsating epicycle. Pulsating epicycle means the radius of the smaller epicycle is not constant. This changes depending on the quadrant in which it is, the first, second, third, fourth quadrant, depending on which the radius of this epicycle will become small or it will become big. And you will ask, why did they complicate it? Why did they do that? It was because of the same phenomena that the Earth speeds up when it's closer to the sun, slows down as it goes away from the sun. How do you model that? This varying radius allowed them to model that behavior. We find there is evidence for that. Evidence is there in Aryabhatian. Evidence is there in in Surya Siddhanta. Do you find for Ravi, there are two radius over here. For Chandra, 2 radius. For Kuja, 2 radius. Buddhan, 2 radius. So this is evidence of our pulsating epicycle that we see. There is also elements of calculus. What is the maximum equation of the sun? They've even done that with exactly what we do in calculus today, taking the d by dt and setting that equal to 0, and you get the answer. We find that Bhaskara II, he has done this in Siddhanta Shiromani. We find these kinds of things. So amazing things are there. If we devote our time with our modern understanding, we go back and examine these works, we find great, amazing things that our ancestors have done, but hidden away from Western historians. So the Indian procedure was, first of all, I find how many revolutions in the Mahayuga. Surya Siddhanta tells me that. Then these constants are known at Kali Yuga time for Ujjain. I find out the Ahargana, how much of time has elapsed. Then I find the mean position from Kali Yuga. If I have the mean position, I do the Desantara correction for local coordinates. Then I use epicycle theory to compute the actual position using trigonometry and other things. Then some additional corrections are needed for time and other non-idealities. So this is the way our ancestors were keeping track of position of Sun, Moon, Mercury, Venus, and everything, which is basically orbital planning. They're doing orbital tracking over here by doing these things. And we also see a dynamic tradition where from the time of Aryabhatta, it was this kind of a model, Surya Siddhanta and others, where Earth is the center, Moon goes around the Earth, Mercury, other things. By the time you come to, I'll show you in the next slide, and there's a pulsating epicycle that I talked about, contracting and expanding depending upon the quadrant in which you are. Then the two epicycle model, also important for the retrograde and other kinds of behaviors. I think I didn't add that other slide. Other slide I wanted to show you was Nilakanta Somayaji. Nilakanta Somayaji lived around 1400, current era in Kerala. He was the Kerala School of Math. He did not use Aryabhatta's model. He said, yes, the Earth is at the center, Moon is going around the Earth, the Sun is going around the Earth, but the planets Mercury, Venus, Mars, Jupiter, Saturn are all going around the Sun. It is a partial heliocentric model that Nilakanta Somayaji proposed. The same model, I got the transmission route. It went through a Portuguese admiral who was a friend of Tycho Brahe. It went to Tycho Brahe in Europe, and he proposed the same model about 100 years later. So this is examples of transmission of Indian works to Europe, and the Indian sources are completely hidden in Western historians of science. Last topic, study of Greek and Indian models. Professor Dr. Anil Narayanan, he's a researcher in Washington, D.C. So he published this paper where he studied this pulsating epicycle of the Earth, of Indians. He showed that the Greeks also have the same epicycle model, but for them, the epicycle is constant radius. For Indians, it's a pulsating epicycle. And using that, he wanted to see if I'm going to predict the longitude of the sun over one entire year, how much of error is there using epicycles in the Indian model? If you consider 100 current era or the year 2000 current era, what is the error in the Indian model? What is the error in the Greek model? Dashed line is Greek, solid line is Indian error. So this from first day up to 365 days, he's tracked this. And you find that the Indian error is much smaller than the Greek error. The Greek error is much, much greater. This is what we find. And this was also observed by Brennan. Brennan was a colonial historian in 1800s. In 1896, he wrote a book called Hindu Astronomy. You can download that in Google and see that. He said the epoch of Surya Siddhanta's solar epicycle parameters was accurate around 3500 BCE. I am as shocked as you are, but it is accurate in that time frame. So what Anil Narayanan did is he wrote a computer program to simulate this. He wanted to find out when is the error the least in Surya Siddhanta. He started with 2000 current era, went to 100 current era, to 1000 BC, 2000 BC. Error is reducing, as you can see. When he went to 5000 BCE, you have the smallest sinusoid over here. This error is the least. So it is shocking to know that in that period of time, the Indian epicycle model that I just described to you, the error was the smallest. What does this tell us? I'm afraid to even make a declaration saying that our mathematics was already ready by 5000 BCE. It is 7,000 years ago. There are other evidences that show that this is not so fantastic, but that's for another talk. It takes a lot of time to describe those things. So in conclusion, what I've done today, I hope I've given you a flavor for the cosmology of ancient India. I examined cosmology in Vedic literature. I talked about observational wisdom and stories, the various phenomena observed by our ancestors, Sayana and Nirayana methods, how that led to observation of precision, then on calendars, the ideal elements, the non-ideal elements. Then we talked about planetary theory. We talked about mean motion and true motion. Through these, I hope I've given you a wonderment that what did our ancestors accomplish and how much we have forgotten what the accomplishments that they have made. So those of you who are unfamiliar with my talks, you might like to Google for my name on YouTube. There are several talks of mine, and you might want to see some of this. This will give you the background material for some of the assertions that I've been making, but it did not explain the antiquity of the Indian civilization, the evidences for that, and why whatever I've said today has got great support in the history of our knowledge systems, the historicity of knowledge systems. Okay, I will stop over here, Suresh ji, and I'll transfer it over to you.
Yeah, Dr. Raj, it's kind of, it's like an overload of information sometimes. There's so much of mathematics, physics, everything that is built in. And just to let you know that I come from a place, a village, which is just about 7 kilometers from where Madhavacharya lived.
Ah,
It's a place called Karvanur, and which is about 6 kilometers from Irinjalakuda, where
hmm,
Madhavacharya lived, and here the Kerala model of mathematics, one of the places. And a lot of research is being done now by different
wonderful.
mathematicians on
Hmm,
his formula. It is written on the traditional mode of poetry,
hmm.
mathematics written in poetry. Imagine that kind of work was done in those times. Amazing kind of
Kattapayadi, Kattapayadi.
kind of yes, correct. So we have to be extremely proud of what our ancestors were when we talk of other mathematical or other physics or other chemistry stuff from Greek or other mythology or other stuff, we also were equally good, if not better. And that's what Dr. Raj tried out. And I have some questions for you, Dr. Raj. I've listed it out and I will read them one by one. I don't know how much time I have. Chandrasekhar ji, you need to tell me. We are at 7:32 now. So
Yeah, yeah, about 10 minutes will.
fine. So what I'll do is Sharati Motmari asked a question. If there's an opportunity, I'll be happy if Dr. Raj and Suresh to discuss an apparent anomaly I see when our Hindu calendars are allotted to various time zones. If time zones progress from east to west, this is for us to understand. However, our Thiris progress from west to east. For example, Vinayaka Chauthi comes first for US, Europe, and India, and then Australia. Why is this happening? Is there any flaw in our Hindu calendar assumptions on the rotation of the moon? The question is
That
for you,
is
sir.
That's a very good question, and I must admit that I don't know how to answer that coherently for you. But we have seen that Indians certainly were tracking the planetary bodies with great accuracy. Like I said, starting with mean motion and going on to local corrections, Desantara, which is what you talked about, tracking for different time zones. Desantara correction was done, and several other corrections for time. They were tracking time and other such things. They were doing the corrections. So why are the tithis? Why are they proceeding one point to the other? I had to think about that. I don't have a good answer for you. My apologies, but I will think about that and try to correspond with you, Dr. Sarathi. You're on mute, sir. Suresh, you're on mute.
Sorry, sir. Yeah, because there's some Ganesh procession going on in the next lane, so I can hear the music go up. That's why I put myself in constant mute. It's a thing that you got to live with during this time. Chaitanya Yamanana, I'm sorry, I got your second name wrong. I think so. So Chaitanya Varma, I'll call you. Please write a book, Dr. Raj Vedamji. I'm sure that you've written books, plenty of them. Maybe you can list it out in the chat, or even Raghu or Mr. Chandrasekhar can share it at a later date. I'm sure you've
I
written a lot
wish
of books.
I wish I had books to offer over there. Other than my PhD thesis, I don't have a claim to any book.
So it's time you can write. So
These are
suggestion is
works in
taken.
progress. These are works in progress. I hope it will
Wonderful.
come
I'm
to
sure there'll be
conclusions.
bestsellers. There'll be
Yes.
bestsellers.
Thank
The
you.
third thing is, of course, the question was about from Betam Charla Shabda about wonderful presentation. If it's uploaded on YouTube, we will be lucky to watch it again and again. And the answer was given by the admin team saying that it is being live streamed and they can watch it on that. So that question is also taken. And Dr. Maushmi Chattopadhyay, same question, can be uploaded on YouTube? I think that answer has been taken. In fact, Rajesh Kumar, the admin team, has listed down all the Facebook, Twitter, YouTube, Instagram, and Telegram links in the chat box, so you can pick it up from there. There's a correction of one of the names you mentioned, Mr. Betamcharla Sharda has pointed out. It is Malli Nathasuri. That is,
Okay,
I
no,
think,
not Mallikarjuna. I said
yeah,
Mallikarjuna Suri. Okay,
yeah,
thank
it's
you. Thank
Malli
you for the correction.
Nathasuri. Suri is the correction given there.
Thank you.
Mr. UK Pandey has a question for you. Dr. Vedam, please inform is there any book on Indian Vedic astronomical knowledge in Indian language available for common man's understanding?
Good question. Some of the things I've used in my course to teach the basics are from Professor Balachandar Rao book. He was a professor of mathematics in National College in Bangalore, Basangudi, and he's written this excellent book that shows the ideal calculations and the non-ideal calculations. So I'd refer that, but it is in English. I don't know if it is available in Kannada or other his language. I'm not very sure about it, but please do look for it. It's called Indian Astronomy by Professor Balachandar Rao. And that's an excellent introduction to computational aspects of astronomy, Indian astronomy. You're on mute, sir. Sureshji, you're on mute.
Sorry, I've come back again.
Yes.
So the two questions from team Varahamitra Panchangam. One is, of course, kindly educate us about the spread of nakshatra length. And I'm a novice on this. I'll just read it out to you. 13.333 into 27 equal to 359.991, 360 degrees. So is every nakshatra of fixed duration, or is there another school which says they have unequal divisions?
I
Appreciate
already
your.
covered that.
Yeah,
I
yeah, I
covered
remember
the
that you said that.
non-ideal.
Yeah, yes,
Yes, yes.
correct. I remember that you said that
Non-ideal. Sorry.
Punarvasu is 1.5 times and all that you were mentioning
Yes,
that. I
yes,
remember that.
yes, yes. The system of Garga, which Brahmagupta is talking about, that there were a different set over there. Even observationally, you can make out that the nakshatras are not all of the same length.
Got it. The second question was from, according to you, when is zero Amavasya period? Are there any methods by which we can scientifically explain?
Zero Amavasya period, I need to understand what do you mean by that?
Well, I need to
Oh,
go back to
not
the.
Amavasya, is Ayanamsa.
No, so Ayanamsa period.
Yeah, that's
Sorry, sir.
different.
I'm
Ayanamsa
sorry.
is different.
I
Yes.
typed it as AV, so it's
Yes,
AY.
the Ayanamsa is a difference between the Sayana and the Nirayana systems. And so this is a matter of opinion in various people. It's a very good question, actually, because I've thought about it a lot too. So this is, we refer to something as the first of Aries. First of Aries is this Mesha Rashi. So according to that, when does something come into Mesha Rashi, the vernal equinox starting over there, or any marker that you want from there? So if at some period of time the Sayana Nirayana system coincided the first of Aries, some people say the time of Aryabhatta, that's when it was. Then there's a slippage over time because of precession of equinox. The sidereal and the synodic things will change. Sayana and Nirayana will keep changing over time. In fact, the time of Lalla, he had said there was 6 degrees of Ayanamsa. So we have to research it a little more. I know there's short period of time I can't talk much about this, but why is there, when is the zero period? To talk about that, we'll have to research a little more. First of Aries is our starting point.
Yeah, then one question that has just come in. Is there any academic center in India that is somewhere close to this work of yours, sir, Dr. Raj?
For which work, once again?
It's close. It says, is there any academic center in India that is somewhere close to this work of Dr. Rajam in US? He basically means, is there some place where they can go and get some more information on the work you're doing, sir?
Oh, okay. There are several. See, my own guru, the way I refer to the people I learned from as my gurus. So Professor Subhash Garg, he's written a lot on cosmology. From the 90s himself, he's been writing articles. I learned a lot from his early works and so on. And there are several other works, but I think what we are after here is our understanding from modern physics, mathematics, and astronomy and engineering. We are using that prism, that darshana, to try to, our drishti, to try and see what did our ancestors do. So we have a better understanding instead of dismissing their works as primitive or not relevant and so on. That is what I'm trying to do. I'm not sure who else is doing this kind of work, but there are several excellent authors you might like to see. Start with Professor Subhash Garg.
Yeah, that question from Yogesh Yadav. We all know astrology with its muhurtas are able to achieve desired results by harmonizing the cosmic energies at that time. And he says, when I saw your presentation, especially the slide where you show the tools that we have used, astonishingly similar tools or symbols that are used by Freemasonry. Is it possible that this knowledge that originated from Bharata migrated to ancient Egypt and then somehow this advanced knowledge got into the hands of the secretive Freemasons to achieve these material goals? If
Okay.
yes, then I feel our knowledge, we must do something about it. Please enlighten.
Good question. So I presume you're not familiar with my works. I have addressed this exhaustively in my Historicity of Indian Knowledge Systems. I first established the antiquity of Bharatiya civilization. Then I say an ancient civilization must have evidence of accumulation of knowledge in medicine, in astronomy, in mathematics, the arts, and other such things. And I show that evidence. Having shown that, I also show the contact India had with other civilizations at that period of time, and when did knowledge go out. In doing so, yes, I do show knowledge transmissions to Egypt, to Mesopotamia, and to several other places with evidence. I'm not only asserting this jingoistically, there's a lot of evidence for these things. So please do take a look at my talks. And those of you who are in Hyderabad can come tomorrow to Triple IT in Hyderabad, where I'm going to give a talk in person on talking historicity of Indian knowledge systems. I'll address these things there.
Time would that be, sir, Dr. Raj?
There are 6 o'clock in the evening tomorrow at Triple IT. I will. Yes, I'll post it on my Facebook also, the poster. So you'll have the room number and everything.
The one question that the user has no name, so I have to just ask the question. All science is available in India on astronomy. Why have we not challenged, for example, the electromagnetic spectra, 7 colors UV before and IR after, representing invisible planets which are represented by Rahu and Ketu? Why have we not challenged or copied science that Westerners have taken away?
So this is when we make such questions, we must also be careful that we can support these claims, right? So if we talk about electromagnetic spectrum, it's not only the visible range, which is a very narrow portion of the spectrum, right? So you've got so much of invisible nature to the spectrum, whether you're talking radio waves all the way to X-rays and gamma rays, you've got phenomena which our eyes simply cannot respond to. The frequency response cannot match that. So if we claim that Indians knew that, we have to try to give evidence for that. Maybe there's a metaphoric thing that we have not understood, and we might try to say that. But we must also say, how would they have understood that? Of course, you can say Rishi Kanada has already worked on atomic theory, and so from atomic theory emanates everything else today's understanding, right? When you excite an electron, it jumps to higher energy levels and comes back, releasing energy as h nu, and all these kind of things. Physics teaches us these things. It is basically from there you got the various radiations coming from this atomic phenomena. We must then say, yes, our ancestors knew atomic phenomena. Can we do that? To some extent, we can say, yes, atoms of different type was talked about by Rishi Kanada and others, and particularity of substance, color of substance, and all these kind of things. But to show that they knew electromagnetic spectrum, I would be a little careful. But I'll give you one amazing insight. Amazing insight. This is there in the Bhagavad Gita. When Arjuna is begging Bhagavan Krishna, show me your Vishwarupa, Bhagavan says, you cannot see me with those eyes of yours if I show who I am in my entire presence. Then he gives him the divine eye, through which Arjuna is now able to see not just the visible spectrum, he sees everything. And he is then so terrified because the world is different from what he has seen. Imagine if you could see an ultraviolet and infrared. The world, the universe will look very, very, very different. Not only that, he could see even much beyond that. That's what Bhagavan's Vishwarupa is. So there's a tantalizing hint over there. Tantalizing hint that our ancestors have understood there's more to phenomena than visible. I posted an article of this on Facebook a few years ago. You might like to go and see that.
Yeah, there is a question from asking for your contact number. I'm sure the organizers can give it. It's for inviting you to the BHU alumni function in Hyderabad. And I think there's UK Pandey asking this question. Couple of last questions before we close the session. OnePlus, it's come from a OnePlus phone, so there's no name on it. Confusing Yuva system in millions of years, while Yugas changed in thousands of years in English calendar. So I'm not sure if that is if you got the question right, sir, but that is the way it has been asked.
So the Yuga system, there we had many Yugas. In the Rig Vedic period, we had 5-year Yuga period. In fact, even Vedanga Jyotisha is talking about 5-year Yuga. So different Yugas came with desires to synchronize various celestial body movements. That's where it came about. At some point of time in Srimad Bhagavatam, we had the Chatur Yuga in much smaller time frames, like 2400 years and so on. Pretty small time frames, all adding up to maybe 24,000 years totally. But then in the same period of time, the Siddhanta period, we got a multiplier by 360, where each divine year was seen as 360 human years. So with that multiplier, these huge numbers came about. That's how the Chatur Yuga became 4.32 million years. And then each one goes 4 to 3 to 2 to 1 ratio. They go to higher and higher numbers. And then we are left wondering, wait a minute, theory of evolution does not say that. We only evolved 200,000 years ago. But here we are talking about 4.32 million years. Treta Yuga, when is it? So we are confused. We don't know what to believe over there. But the point is, my understanding is, or rather my hypothesis is that these bigger Yuga cycles were helpful when you saw Surya Siddhanta saying in a Chatur Yuga, how many revolutions of sun, how many revolutions of moon. It was necessary so that you don't have to carry the decimal point. Not that they did not know decimal, but they wanted integer, whole numbers. Whole numbers could be remembered much, much easier, I believe, in that early period of time. So many of the Siddhanta astronomers only needed to mug up those few constants. With those few constants, they could do back of the envelope calculations and quickly tell you the mean motion where any body is at any given period of time. So my belief is for carrying precision, arithmetic precision, these huge yuga cycles were invented, and that helped them to do it.
Mr. Vijay Totapalli, your question came in just now, and I'm sure that you know that we have run out of time. We don't have much time, and I've asked the organizer, but the question was, can you tell us similar planetary positions earlier? What was the events in those times? I think it was related to something else, but it looks like a bit question that is not complete by itself. But I'm sure that we can, Dr. Raj can answer it offline once in the chat mode, or the organizers can get back to you. I leave it to Mr. Chandrasekhar now to take over from here, sir, and kind of close the session. And Dr. Raj, it's been wonderful. So I'm not sure whether I should be saying the vote of thanks or saying thanks to you, but for me, it was education. As a student would sit at the feet of a guru and learn. I mean, there's an amazing amount of work which our ancestors did, and we should be proud of our civilization and what they've achieved in terms of the scientific knowledge. Mr. Chandrasekhar, can you please take us?
Thank you, Sureshji. Yes, now that the question answer session is over, we can wind up the session by proposing a formal vote of thanks. But just before that, a reminder to the audience, Pragna Bharati is very much present on the social media. The handles have been seen on the chat as well. And we are there on Facebook, Twitter, YouTube, Instagram, Telegram. So my request is you please subscribe and follow us on the social media, and then make sure that it spreads to other friends and relatives, so that the good work we are doing can spread to more people, and we can do a lot of better things in future. And now I'd like to propose a formal vote of thanks on behalf of Pragna Bharati and everyone present here. I sincerely thank you for your enlightening presentation on cosmetology, sir. The way you explained such vast and complex subject with clarity and passion made this session inspiring and engaging. Um, in fact, this session has broadened our understanding of the universe and sparked curiosity to explore further. I'm sure a lot of questions have been asked by people, and they're more interested in the subject. Thank you for that, and we're truly grateful for your true and time and effort you devoted to sharing your knowledge with us. And we actually look forward to having another session in near future. Thank you so much, sir. Dr. Vedam.
Thank you. Thank you for inviting me. It's a pleasure to come and talk at Pragna Bharati. Thank you so much for inviting me.
Thank you, sir. Thanks, the audience. Thanks to Sureshji and also the audience who are present here. And please follow us, and then please keep attending our further meetings in future. Thank you so much. Good night, all.
Yeah, request the admin to kind of close the window so that everybody can exit the system. Thank you very much, Dr. Raj. Thank you.
Thank you for moderating. Thank you.
Thank you, sir. Thank you very much, sir.